Hello everyone, welcome to Civil Mania. So in this video I'll be telling about STAAD Pro, how to use STAAD Pro. So let me open STAAD Pro. Yeah. So in the STAAD Pro, first of all let me click on new project. See, in the new project, as I have said the basic unit as meter. In the configuration part, as I can show you once more, select base unit as metric. So as I have selected here metric, so if I will be opening a new project, so here the length unit will be in meter and the force unit will be in kilonewton. And if you want to change the unit to a different one, you can change it, like if you want in foot and this one in kilo pound, so you can change it, but as per my requirement it is in meter and kilonewton, because I am in I will be doing the numericals as per Indian standard. So I have selected meter and kilonewton. Then here these are the various boxes which I can select, like space, plane means 2D. See, in if I will be selecting space, a space is a structure which is a three-dimensional framed with load applied, means in the space we will be creating a 3D structure, in plane a 2D structure only in x and y coordinate. A floor, I hope it's clear to all of you what is a floor and truss. So I will be selecting a space, then next, then here you can select any of this except edit job information, like add beam, add plate, add solid. So here I will be selecting, or directly you can open structure wizard. What is structure wizard, I will clearly show it, but first of all let me open as a add beam. Click on add beam and finish it. So I will click finish. After clicking finish, as you can see here, this is the interface which opens. So I hope you can see here, this is a one type of grid system. If I will be clicking, if I will click this button, the grid which is in a inclined manner, it will become straight. See, and here you can set the coordinates like this. You can do one thing, like let me first set as this is the first point of the beam, then the second point of the beam is at a distance of 4 meter, then third point of the beam is at a distance of 8 meter, and after that you can press escape. I hope it's clear to all of you. So this, by the help of this grid system, you can directly draw the beams, columns or frames or any kind of structure. And here as in the grids, its starting point is 0 and its end point is on x axis and y axis, both are 10. So even you can edit it, here you can edit it and you can keep as 2 meter grid. See, every distance in the x axis has become 2 meter, in the y axis also I can change as 3 meter. So here it will become 3 meter. As soon as I change it, see here you can see here it's 3 meter, 3, 6, 9, 12, 3 meter, and how many kind of how many number of intervals I can keep here, like 10 or 11, all this you can set here. Okay, so in the edit section you can go and you can set, but I will close this part. You can either close here by clicking this, or simply you can click here and close it. See, I have clicked here and I have closed it, or I can again click it and I can show this grid system, or I can directly click on this cross and I can show it. So this is the beam which I have drawn. As you can see here, let me delete this part. Or let me draw another one grid. See, I have selected this grid point. So let me click by the help of the, this is a one kind of node cursor. So I will select the node cursor and I will delete this one by clicking the delete button and press enter. So again I can go to my coordinate system. As you can see here, this is a one kind of beam which I have created here, and this I have created it in my geometry section. You can go in this geometry section. After going to the geometry section, or simply you can enter here the details. 0 0 0 is the coordinate of this point, then 4 0 0 is the coordinate of this, and 8 0 0 is the coordinate of this. I hope it's clear to all of you, the coordinate system. After that, after going to the general section, after going to the geometry, now I'll go to the general section. In the general section, I will provide the as you can see here, properties whole section. So here I will define the properties. So whether the beam which I have drawn, whether it is a type of circular beam or rectangular beam. So I'll let me provide a rectangular beam of size 0.23 and 0.4. So its width is as you can see here, ZD is the width and YD is the 0.23, which is the depth. And as there are two span here, so let me provide another one as the 0.4 by 0.6 add. See here, all those values you can add it as per your choice. Now here the nodes are not showing, so you have to go to this section and you can click it. So as you can see here, these are the nodes which are shown, or simply you can go to this symbols and labels. This is the part symbols and labels, and you can click on node points and you can apply. See, it will show all the node points. Now directly you can select the first rectangular size of and material. Remember that even if you do something anything wrong, you can go to the edit and you can again edit it, and here the material by default I have set as concrete. Okay, now click on this one and see, use cursor to assign. I will assign it first of all, then I will click on the left hand side. So see, this one is R1. R1 means reference 1. Now I will click on 2. So here I will again select R2. So I hope it's clear to all of you how to assign the properties in the general tab. This is the general tab. Here I will assign all these properties. Now close it. After closing it, maximize it, and I can show you in 3D diagram. See, I hope it's clear to all of you. This is the beam which I have created of different rectangular section. Now see, first of all in the geometry section I have drawn two span. Even I can show the two spans, their length. So go to this symbols and levels, and here you can beam number you can set, beam orientation you can set, okay, load values you can set, beam specifications you can set. See, all I have set here. Let me do one thing, beam orientation, remove it. Beam numbers is okay, that is beam number 1, beam number 2. Load values I have selected it, it's okay. But if you want to see this dimension, that is beam number 1 is equal to 4 meter, beam number 2 is equal to 4 meter, just click on this dimension. This is the dimension here, and dimension to view, just display, click on display, it will show you the dimension. So this is how we have to draw the beams. So my first step is to draw the beam by the help of coordinate system. Now I will assign the properties to the beam. After assigning the properties to the beam in the general part, now I will go to again the general part. In the general part, property I have assigned. Now I will go to the support part. In the support part, so in the support section I will be creating. First let me click on select, and in the select click on create. In the create, see these are the various type of supports. I can select fixed support, then pinned support. Pinned means hinge support, and if you require roller support, then so see here there are 3 points, node points A, B and C. In the 3 node points I will create different support. So let me first of all create fixed support. Click on add. See this is the fixed support. Then click on hinge. This is the hinge support. And third, click on roller. For roller you have to click on this, and remember that in the roller support you have to release all except Y. I hope all of you know about roller support, that in the roller support there is only one unknown, that is vertical force, vertical reaction. So this is the vertical reaction, and other you have to release it. So add. So this is the one kind of roller support. So let me assign. Click on first of assign from the beginning. So first of all, support 2, click on this fixed support, use cursor to assign. This is the fixed support. Now let me click on the roller, hinge. Here hinge support. Now click on roller. Here it is roller support. So these are the various 3 supports I have provided. Now after providing property support, then let me go to the load section. In the load section, you have to first of all go to this load case detail and click on add. See, remember that there are various type of load. Primary load in here, primary load, there are various type of load: dead load, live load, roof load, wind load, seismic load, snow load, fluid load. All these are the various type of load, and this is load number 1 and load case number 1. Again there are load generations, then there are the various combinations. We can define the combinations, like what is the factor of safety we will be providing for dead load plus live load. That is what I hope it's all of you know, that the factor of safety which you provide for dead load and live load is 1.5. So we can I'll show all the type of loads in the subsequent numericals, but let me, and this is the auto load combination. So load combinations will be automatically assigned. So I don't have to show everything. So let me do one thing. Let me close this one. First of all, in order to assign the load to this beam, simply go to load case detail and click on add, and here simply you click on add. Okay, you don't have to change anything. Keep it as remain as none. Now go to load case, then click again add. Now you have to select what kind of load you will be providing it in these 2 span. Let me provide in the first span as UDL, uniformly distributed load. This is a one kind of uniform force, the uniform, but remember that concentrated load, UVL, UDL, all these will be present in the member load. So you have to go to the member load, and here you have to click uniform force, then uniform moment. So you have to click on uniform force, and remember that let me provide the UDL of 20 kilonewton, but I will provide minus because it's clear to, I hope it's clear to all of you that why I am providing minus, because minus means downward direction and plus means upward direction as per the coordinate system. So I will be providing the load in the downward direction, so minus 20. Then D1 is this distance, D2 is this distance, and D3 is the transverse distance. So I will be providing either D1 or D2. But if I need to apply for the full span of the beam, simply keep keep it as 000. You don't have to add anything else. Simply click here add. See, I have click on added. So here uniformly distributed load in the global y axis. This is y axis, the y direction. I have applied the load and minus 20 kilonewton per meter. Now after that I have added one UDL. Now let me add one concentrated load. So concentrated force of, let me add 10 kilonewton load in the global y direction and at a distance of how much? Let me apply at a distance of 1 meter. So here I will provide 1 meter, okay, because you can see here this is the beam. Add it. After clicking on add, see this is 1 meter, close it. See, now I will apply the load one by one. Click on this load, assign to, use cursor to assign. Here I will click here. See, this is minus 20 kilonewton load I have applied. Then click on this load. I will click on this beam. So this is the load which is applied. Now go to the scale part. In the scale part, the load scale which is present here is apply immediately. See, point force. See, I have increased. The reason of increasing the point force is I am showing its height. See, I can increase and decrease its height, but you have to click on this button. So point force of 10 minus 10 kilonewton I have applied here. Click on apply, OK. Where I have shown this option? In the scale, this. So this is the load I have applied now. Now let me go to the analysis part. Now let me go to the material. I have already selected as concrete in the beginning only, in the property section. So let me directly go to the, see, in the first step I have drawn the beam via coordinate system or via grid system. Then in the second part I have assigned the supports, then I have assigned the loads. Now I will do the analysis. So you have to click on this analyze and print, and simply no print, and simply click on add. See, perform analysis done. Now close it. After closing, go to this analysis part and click on run analyze. Save it. See, 0 errors, 0 warning. Remember that if in your diagram warnings comes, then it's not a problem, but if errors comes, then it cannot proceed further. So you have to check for the errors and you have to remove the errors. Now you can view either the output file or you can go to the post processing mode. Now let me go to the post processing mode and click on done and click on apply. OK. See, these are the various results you can see here. For the analysis part I have done. Even you can go to the, I hope all of you know about shear force diagram, bending moment diagram. So if you need to check for the deflection diagram is already clicked here. So I can uncheck it. See, I can check it. So this is the deflection diagram, but here the deflection is not showing. The reason behind this is the, first of all, let me go to the result here, and in the result section I will set the view values. Here I will set view values, and here beam results and deflection part, displacements, annote. Bending moments also I will annote it. Annote. OK. OK. Now let me go to the scale, and in the displacement part 1000 is there. Apply immediately, and let me remove here 1000 to, let me decrease it here. let me decrease it here. I hope you can check the deflection diagram. This is the deflection diagram, and this is the displacement values. Directly click on apply and OK. So these are the various displacements or deflections which can be seen in this beam. Now let me again uncheck it. Then now let me go to the moment Z. This is the bending moment diagram. Again I can go to the scale and I can bending moment along Z. I can keep the value as 10. Apply or apply immediately, and you can increase and decrease it. This is the bending moment diagram. Okay, now you can again uncheck it. Now you need to check for the shear force diagram, that is shear along Y. This is the shear force diagram. So here you can go to the scale part and shear Y, yeah, this is shear Y. You can reduce the value to 10. Apply. Okay, so this is the shear force diagram along with the values. Or if there is any problem, simply you can go to this beam cursor. You can select the beam and you can double click on the beam, and you can go to the properties, like this is the shear portion, and this for this beam the shear forces at any point of the beam you can check here. In this box you can check here the shear force at any point of the beam, at a distance, at any distance. Let me check at 2 meter distance. At 2 meter, what is the shear force? This is the shear force distance, and this is the bending moment distance. This is how you can check for shear force and bending moment distance values at any point of the beam and in any sections. I hope it's clear to all of you. So how to do the analysis, but remember that in this numerical I have not done the designing part, but in my subsequent videos I will be again showing for the designing part as well. So I hope it's clear to all of you. So thanks for watching my video, and if you have not subscribed my channel, then please subscribe my channel and place the like button if you liked my video, and share as much as possible. Okay.